Hello. Today we're going to just continue our discussion about weather. Our last discussion was about severe weather. Today we're going to talk about forecasting the weather. So you can see from the slide that we already know that meteorologists gather information using weather instruments. So we talked about an anemometer, a barometer, wind vane, weather vane, um, not weather, windsock, and a thermometer, right? So they take this information and they use information that they collect from data stations and from computers, and they use it to make predictions about the weather. So they get the information, they look for patterns, and they predict the weather. So severe weather is dangerous, but if we know that it's coming, we can prepare for it, right? So it can save lives. If we know a hurricane is coming, we can protect our house. We can leave. We don't have to stand there and see what happens. So predicting the weather is important. These are weather balloons. Weather balloons go as high up as the stratosphere, which we know is the second layer from the Earth. And attached to it, you see this box here. Attached to it, in that box, are weather instruments. And they take readings on the way up and maybe on the way down. And once it gets high enough, the balloon is probably going to freeze and break. And here's a parachute. And as it's coming down, the data is being sent from the box to data stations, to meteorologists at data stations. In the United States, we release 92 weather balloons from 92 different stations around the United States twice a day. And we release them into the upper atmosphere because you can see more from there. You can see the storm systems that are developing. You can see what's happening hundreds of miles away. You can see what's coming. So you're able to predict for cities that are in front of those weather systems what's coming to them. So last when we spoke, we were discussing station models. Now, if I were to take all the information that I got and write it for each city, so if I would take the temperature and write it here, and then the sky, the cloud coverage, and write it here, and the dew point, and the air pressure, and the wind speed, and the wind direction, and I did that for each and every city, and then I had the fronts on here on top of that, this map would be covered with weather data and no one would be able to read it. That's why we use station models. You put the station model on the map, it's tinier, it's more condensed, and you're able to read all the information that's on it. Like for here, for Denver, I can tell you that it's 76 degrees, the dew point is 57, the wind is coming from, I would say the west, southwest, slightly southwest, at 10 knots. The cloud coverage, it's mostly cloudy, and the air pressure is 183. I didn't need to write any of those words out, so it makes it easier. We also talked about isobars. Iso means the same. Bar represents the barometric pressure. Some people call it the air pressure. So isobars connect points of equal barometric pressure. And you can see that here, see that 1016, 1016, and you can see it here. Also on maps, not on this one, you have isotherms. We know that therm means heat. So isotherms connect points of equal temperature. If those were on the map, then it would look very similar, except these numbers would be temperatures. Something else you should know is that the spacing between the isobars will tell you how strong the wind is blowing. The closer those isobars are together, the stronger the wind. Look at here, a little bit of space here between here, and you see all this big space here? The wind here is gentler than the wind here, or the wind here is stronger, is blowing stronger than the wind here. So that is basically our weather unit in a nutshell. We will have a test soon, so go back and study, and also view the video on your homework.